Okay, so now that we've spent all of this time evaluating functions and graphing functions, I wanted to kind of bring in a couple of ideas where functions actually happen in our real lives. Um, there's probably not too many times where you're going to have to use a function for a quadratic or even use an exponential function, but the real world applications of these are actually happening a lot right around us and we just don't know about it. One of the instances where I personally um, I don't use a function but I benefit a function is when I have my money in the bank. I have a savings account, checking account, different things like that. All of those pay me interest. If you're not familiar with the concept, anytime you have money in a bank, the bank pays you interest on your money. Basically, they pay you for having your money in the bank. Now, usually it's a small percentage of your money that they pay back to you. But what happens is, they pay you this interest into your account. And then the next time that they calculate your interest, you have interest on top of your interest. So it's called compounded interest. So they pay you over and over and over for keeping your money in the bank. So the formula that they use for this looks really complicated, but it's not. So just take a deep breath before I turn the page here, and let's see what's happening. So there's a lot going on in this formula, a lot. But we're going to be looking. This function basically has multiple inputs. Okay, there's not just a dollar amount that you have to worry about. There's a dollar amount and then the percentage that the bank pays you. And then there's how long you leave the money in the bank. And then there's actually how many times a year that they're going to calculate this for you. There's one thing that I want to add here, just because the number of times the bank calculates your interest is actually it's twice. It gets used twice in this formula. So I'm going to draw that second arrow there. Like I said, this looks way worse than it is. This is basically today, tomorrow, the number of days we spend on this. It's basically, can you use your calculator? I'm going to give you all the information. You just have to put that in the right spot and do the math. There's no equations to solve. There's no graphs to do. So this is simply an exercise in arithmetic. So all the different pieces have different meanings. So we are going to be calculating the A. This is what we're going to be trying to find every single time. I don't want to press our luck and try and make it more difficult, like where you're trying to figure out how many times or how many years do you have to leave this money in the bank. So every single time we're calculating the A. The principal, okay, that is the dollar amount, the money that you put in the bank. Okay, your interest rate is always listed as a percentage. Now, what you'll have to do is one little thing that you're probably familiar with. Like, let's say our interest was, I don't know, whoops. Let's say our interest rate were 3%. You've got to change that percent to a decimal before you can do the arithmetic. So the way you do that is you take the decimal point and the percentage right here, and you're going to move that 2 places to the left. So this would actually be 0.03 as a decimal. Okay, so you're going to have to do that on all of these. Anytime the percentage is listed, take that decimal point, move it 2 places to the left, and that's your number you're going to be working with. The N is used twice. It's used in the denominator here, and it's used as part of the exponent. We'll talk more about that when we get to it. But the N is how many times a year they calculate your interest. Me personally, at my bank, they do it every single month. So that would be 12 times a year, January, February, March, so on and so on. Some places only do it quarterly, which means 4 times a year. And I'll show that again here in a minute. And then the last piece that we need is time. How much time in years are we going to leave this investment or this savings account or whatever just setting alone and not messing with it? Okay, so it sounds like there's a lot going on here, but again, this is just a plug numbers in and do the arithmetic. Okay, so again, the two things that you need to know, these are pretty common. for your values for in. Some of these you'll be investing your money monthly. It'll be calculated monthly, which means 12 times a year, and sometimes it'll be done quarterly, which means 4 times a year. Now, quarterly, just think four quarters in a dollar, right? 4 quarters in a basketball game. Just kind of keep that in the back of your mind. All right, so let's jump in and do one of these. Take your time. All right, if you invest $1,000, that is your principal, that's your dollar amount, at an annual interest rate of 5%, that's your R. Compounded monthly, that's your N. Monthly means 12. Calculate the final amount, that's what we're trying to find, the A, you will have in your account after 5 years. There's your time. Okay, now I'm going to write this out the exact same way I would type it in on my calculator. Please don't try and do these without a calculator. So I've got $1,000 that's invested. The 1 is built into the formula. If you go back and look, I should have mentioned that earlier. If you go back and look, the formula has a built-in 1. That stands for 100% of the original money that you put in the bank. It's built into the formula. So 100% of the money, we're going to invest that at 5% interest, compounded quarterly, and then our exponent is going to be that quarterly again times how many years. Now, this last part, the 5 times 12, that basically means that they're going to calculate your interest 60 times. 12 times a year for 5 years. So I've got this set up the exact same way I would type it in on my calculator. This fraction is just division. Okay, so when I type this in, I'm going to type in 1,000, 1 plus 0.05 divided by 12, then set up an exponent. When I do my exponent, I'm going to open another set of parentheses and do 12 times 5. Okay, what shows up on my calculator should look exactly like this, parentheses and everything. If you try and skimp and not use the parentheses, a lot of times you'll only be calculating a portion of the answer. So my end result was 1,000. So my end result was $1,283.36. Make sure you're rounding these correctly, 2 decimal places since we're talking about money. Okay, jumping right into the next problem. Your principal is $500. Your interest rate is 10%, compounded quarterly. That means 4 times a year. Calculate the final amount you have in the account after 5 years again. So that's your time. So principal, 500, 1 plus, my interest rate is 0.10 divided by 4. Exponent key, 4 times 5. Okay, that is exactly what it would look like on the display of your calculator. If you're not using a calculator, God have mercy on your soul. All right, 500 times 1 plus 0.10 quarterly, exponent quarterly times 5 years. So out of this, 5 years, you leave this money alone for 5 years, you're going to have $819.31. So you made an extra $319 just leaving that money setting alone. Now that may not sound like much, but this also doesn't account for the fact that if you were to continue to deposit money.